Hey guys, this is Nikhil, and here I am to teach you a few tricks on how to find the remainder when you're dividing any given number by 2, 3, 4, 5, 6, 8, 9, and 10. So let's start. You can see that we have prepared a slide, the tricks to find the remainder. We have given the tricks for 2, 4, 3, 4, 5, 6, 8, 9, and 10. So for 2, it says if the last number is odd, the remainder will be 1. And if it is even, the remainder will be 0. What does it mean when we are dividing any number by 2? We know that there are two types of numbers, odd and even. All the even numbers are divisible by 2, and all the odd numbers are not. So for 2, the possible remainders are 0 and 1. So if any even number is divided by 2, the remainder will be 0, and any odd number is divided by 2, the remainder will be 1. For 3, the trick is add the digits and divide by 3. Whatever the remainder comes will be the remainder for the original number. Let's try and learn it by a different process. Let's see. What is it given? Let's take a number 364. When we add 3 plus 6 plus 4, we get 13. So 13 when divided by 3 leaves a remainder 1. So it means 364 when divided by 3 will leave a remainder as 1. One more example. Let's say 319483094. I'm sure you people will not be interested in dividing the entire number by 3. So for that we have the divisibility rule. We'll add all the digits again. So 3 plus 1, it's 4. 4 plus 9, 13. 13 plus 4, 17. 17 plus 8, 25. Plus 3, 28. Plus 9, 37. Plus 4, 41. So when 41 is divided by 3, the remainder, we know that it will be coming as 2. So for 3, what is the trick? If the sum of the digits when divided by 3, whatever the remainder leaves, the original number will leave the same remainder when divided by 3. So this is the basic trick for 3. We'll now be moving on to the next one, and that is so for 4, what is it? For 4, the trick is divide the last two digits by 4. Whatever the remainder comes will be the remainder for the original number. See, if you observe the divisibility rule for 4, it said if the last two digits of a given number is divided by 4, then it's divisible by 4, then the original number will be divisible by 4. So over here, we are just using the divisibility rule, but this time we are not actually finding the number which is perfectly divisible. We are finding the remainder for that. So how do we start? Let's take a number 3694831. We are not bothered about the entire 8 digits over here. What we will be doing is we will simply be dividing 91 by 4. We know that we will be getting 88. The remainder will be coming as 3. So when 3694831 is divided by 4, the remainder that we will be getting will be equal to 3. Let's take one more example. 4142865. We are just considering the last two digits. So 65 when divided by 4, we will be getting 64 as the nearest multiple by 16. The remainder is coming as 1. So for 4, again we are repeating. For 4, we will be checking the last two digits. If the last two digits is divisible by 4, then the number is perfectly divisible by 4. That was the divisibility rule. But this time, if we are dividing the last two digits by 4, whatever the remainder comes, that will be the remainder when the entire number is getting divided by 4. So this was the remainder trick for 4. Moving on to the next one, that is 5. For 5, it says divide the last digit by 5. Whatever the remainder comes will be the remainder for the original number. All right. Let's take the number as 369487914. We are not bothered about the entire number. We are simply dividing 4 with respect to 5. We know that with the remainder, the range for the remainder is 0 less than equal to r less than the divisor. So we cannot take any number. There is no multiple of 5 which is which is smaller than 4 other than 0. So we'll be taking the quotient as 0. We are taking the we're placing it 0. 4 minus 0, the remainder is coming as 4. So whatever the last digit is, we will be dividing by 5. Whatever comes as the answer, that will be our remainder when divided by 5. Let's take one more example. 3481356949327. What we will be doing is we will simply be dividing 7 by 5. 5 ones are 5. The remainder is coming as 2. So when 3481356949327, when divided by 5, it will be leaving a remainder 2. The number is so lengthy that we're not even interested in telling the numbers. We're not interested in dividing the entire number. So for that reason, we need the tricks. So any number when divided, when the last digit is divided by 5, whatever comes as the remainder will be our desired remainder for the original number when divided by 5. So this was the divisibility rule for 5. We'll be heading on to the next one, and that is 6. Now 6 is a bit tricky. So let's learn it step by step. Add the digits and divide by 3. The same procedure as we did for 3. If by subtracting the remainder from the original number, we get an even number. Why even? Okay. Why even number? Because for the divisibility rule of 6, what is it? We need a number which is divisible by 2 and 3 both. So if it is coming as an even number, then whatever the remainder comes when it is divided by 3, the same will be the remainder for the original number when divided by 6. But if by subtracting the remainder we get an odd number, we know that an odd number cannot be divisible by 6, then another 3 will be added to get the final remainder when divided by 6. So the theoretical part seems to be a bit complicated. Let's learn it practically. How to start? Let's take the number 348136917. The first step, what we'll be doing, will be adding the digits. 3 plus 4, 7, 7 plus 8, 15, 16, 19, 25, 34, 35, 42. All right. So we're getting 42. So 42 when divided by 3 leaves remainder 0. But if you observe, if this number is divisible by 3, but this is an odd number. So an odd number divisible by 3 will not be divisible by 6. So what we are going to do, as per the trick, we will be getting the remainder as whatever we are getting the number 0. We will be adding another 3. We will be getting the remainder as 3. Okay, I'll give you another easy method. 348136917 is divisible by 3, but it is an odd number. So the previous number, which will be divisible by 6 and 3, it will be 348136914. So this number will be divisible by 6. So what is the difference between these two numbers? The difference between these two numbers is what? 3. That is what is coming as the remainder. I'll give you another method for this. Another number. 413849331. 5 plus 3, 8 plus 8, 16 plus 4, 20, 29, 32, 35, 36. So we are getting 36. 36 when divided by 3 leaves a remainder 0. Coincidentally, again, we are getting the remainder as 0. But since this is an odd number, we will be taking the remainder as 0 plus 3. We will be getting the final answer as equal to 3. So whenever we are dividing any number by 6 to get the remainder, what we need to do is we will be dividing the sum of the digits by 3. If it is an odd number, we will add another 3 to that, like this particular procedure. Let's check another one. 4, 2, 8, 3, 6, 1, 2. Let's add it. 4 plus 2, 6, 6 plus 8, 14, 14 plus 3, 17, 23, 24, 25, 26. So 26 when divided by 3 leaves a remainder 2. What we're going to do is we're going to subtract 2 from this number directly. All right. So we will be getting 4, 2, 8, 3, 6, 1, 0. Now you will be observing that this number is coming as what? This number is coming as an even number, and this number is divisible by 3. So when a number is an even number and divisible by 3, we'll consider that to be divisible by 6. So as per the trick, if the number when remainder is subtracted comes as an even number, whatever the remainder comes will be accepted as our desired result when divided by 6. So I'm repeating it once again. If the sum of the digits when divided by 3 leaves a remainder as an odd number, leaves a remainder which when subtracted from the original number is still odd. Like for example, the remainder became 0. When 0 is subtracted from this number is odd. So the remainder that we'll be needing when divided by 6 will be 0 plus 3 equal to 3. But for even, when we're getting 26 divided by 3, the remainder is 2. So when we're subtracting 2 from this number, what are we getting? We're getting the remainder as equal to 2. Right? Directly. We're not going to change that. Moving on to the next one, we have for 8. The divisibility rule for 8 says, divide the last 3 digits by 8. Whatever the remainder comes will be the remainder for the original number. So what does it mean? For divisibility rule of 8, it said that the last 3 digits, when it is divisible by 8, it will be divisible by, the original number will be divisible by 8. Same case for the remainder. 6, 8, 4, 9, 1, 3, 8, 1, 2. We are not bothered about the entire set of digits. We are just bothered about the last 3 digits. So 8, 1, 2, we will be dividing it by 8. It will be 808 by the number 101. The remainder comes as 4. So when 6, 8, 4, 9, 1, 3, 8, 1, 2 is divided by 8, the remainder will be coming as simply 4. Let's take another example. 7, 4, 6, 9, 8, 1, 3, 4, 2, 0. We will simply be dividing the last 3 digits 420 by 8. We will be getting 416, and the quotient will be coming as 50, 52. So what we're going to do, we're going to get the remainder as 4. Again, when this number is getting divided by 8, the remainder will directly be coming as 4. Let's take a final example. 514283. We'll take an easy one. So 283 when divided by 8 will be getting, let's do it step by step. 24, it will be 3, 43. So 40, it will be 5. We'll be getting what? The remainder is 3. So when 514283 is getting divided by 8, the remainder will be coming as 3. The tricks are beneficial because you don't have to divide the entire number by the given number that we have. Only the last 2 digits or the sum of the digits or the last 3 digits will be helpful for us to find the answer. Moving on to the last one, second last one, that is 9. Add the digits and divide by 9. Whatever the remainder comes will be the remainder for the original number. So the divisibility rule of 9 said, if you're dividing any number by 9, if the sum of the digits is divisible by the 9, then the original number will be divisible by 9. Hence, what we're going to do, suppose 9192939498. We're having this number. Just we'll be adding it. 9 plus 1, 10, 10 plus 9, 19, plus 2, 21, 30, 33, 42, 46, 55, 63. So when 63 is divided by 9, the remainder is coming as 0. All right. So this number is directly divisible by 9. The remainder will be 0. Let's take another one. 639, 412, 84. So 6 plus 3, 9, 9 plus 9, 18, 18 plus 4, 22, 23, 24, 25, 33, 37. So when 37 is divided by 9, the remainder will be coming as 1. You can check it by yourself. You will be getting the same remainder. Last but not the least, 10. We don't even have to look at the slide because 3164983097741. This when divided by 10, we know that the last digit of the number will be taken as the remainder. So this was the basic trick to find the remainders when you are dividing any number by 2, 3, 4, 5, 6, 8, 9, and 10. Thank you, everyone. Bye-bye.